All right, on this problem, we are looking at using the idea of forces and directions. And specifically, we want to think about the idea of the tension that is on two cables here that are holding up a sign. So we're going to have these two tensions. I'm going to refer to this one as a U vector and this one as a V vector. But also we will have the weight of the sign, which I'll refer to appropriately enough with a W, and the weight of the sign is going straight down. However, we're given that the two cables that we have the sign hanging from have certain placements that they're set up with. So what we're going to do with this is to say that our U vector is something times a unit vector that is determined by the direction. And so for that unit vector, we're going to take a look here and draw the picture of U roughly like this. And remember that it says it is 40 degrees off the horizontal. So the unit vector we'll get for that is going to be just cosine 40 degrees, sine 40 degrees. Now, I would suggest for you, as we're going along with this, to evaluate cosine 40 and evaluate sine 40 and store them under some variables in your calculator, because this is going to get a little bit rough just from the amount of numbers floating around. Okay? Our V vector, I'm going to put a B out there, and B is just going to be how much tension there is on this cable. And it says that it is 50 degrees from horizontal, but I need you to take a look at the picture and see that the 50 degrees that it's referring to is actually going to be the reference angle. And the angle we actually want to deal with is this 130 degrees. That's its supplement. So cosine 130 degrees, sine 130 degrees, like so. W of all these is the one that's easy. It has weight that's going directly downward, so there is no x component to it, and the y component is negative 50, right? And the key in all this is, since the sign is not moving, or not being moved, we want for U plus V plus W to turn out to be the zero vector, or in other words, 0, 0. So if we write that down, it's going to look pretty awful. A cosine 40 plus B sine 40, and there's nothing from the W, so it ends there, comma, A, guys, I'm sorry, let me back up on that. I just wrote the wrong thing down. It was supposed to say B times cosine 130. I just wrote the wrong thing, sorry. And then for the y part, we'll have sine. We will have A sine 40 plus B sine 130 minus 50, and that's supposed to be equal to 0, 0, which you should pick out. That means this portion needs to be 0, and this portion needs to be 0. So now we have two equations in the two unknowns. So I've just copied those equations over here with the slight change that I went ahead and put the 50 over to the right-hand side. Now, if you'd like, we can also work with the numeric approximations as we go along, which would look like this. Notice just through a coincidence of the numbers that I chose here that we do end up getting this 0.766 appearing in both places and a positive and negative 0.643 appearing there. It's just coincidental. So the first thing that we're going to want to do is to take this portion here and solve for one of the variables in terms of the other. So an easy way to do that might be to go ahead and say that these are equal, and then we can just take and divide by the 0.766, and we'll get about 0.790. Now I'm going ahead and just saving that number in my calculator and not doing the round off, but 0.790b. So if I take and substitute that into this equation here where the a is, it'll become this. And then that becomes about 1.556 times b equals 50, which says that our b equals about 32.126. So then we just have to substitute that back in for a, and that comes out to be about 25.390. Naturally, we need to mention the pounds in each of these. So those are the forces on each of those cables that are holding up that sign that's 50 pounds.